Okay, so I know Stacey because she, like David, is a postdoctoral scholar on the Elite PD project that I'm PI on. And she got her PhD from the University of North Carolina. Her dissertation title was Exploring Mathematical Knowledge for Teaching Quadratic Functions Through Student Work. She's been both a high school and middle school mathematics teacher in North Carolina. And she was also an outstanding teacher at North Carolina Agricultural and Technical State University. We're really lucky to have her on the project along with David. They're both pretty awesome. And with that, I will pass the baton over to Stacey.
Thank you so much, Mary, for that introduction. And thank you all for sharing your research interests. I was really kind of trying to seek and see if there was some connection to my study, my work. And if there's not actually to my work, I think there's probably some connections to the experience. So again, I'm Stacey, and I should clarify, because Mary said UNC, University of North Carolina, I should say Greensboro, just in case you all thought that was the light blue Carolina. I'm a Duke fan, by the way. So I am UNC Greensboro. Is where I did do my dissertation work. And now I am again at Virginia Commonwealth. So I'll apologize ahead of time if you hear any loud noise. I was talking to Donna a little bit early. This is my city adventure. If you know anything about Greensboro, North Carolina, it's very rural. And now that I'm in Richmond, there's always noise here. I was like, I can't get away. And you can probably hear the traffic now. And I am inside, just saying. So a little bit more about my background. Let's see if I can get the slide to go. Yeah. So I do like to kind of start with that. I've told you, yes, I was born, raised, educated, and started as a high school teacher in North Carolina. Again, very rural part of the state. But I took a little break from teaching after several years, and I went and worked in industry, and I became a senior programming analyst for VF Corporation. If you all know Wrangler Jeans, y'all know Wrangler Jeans? Yeah. So I worked for that corporation for years as a programming analyst, which really put my math skills into play. And I always appreciate that time because I eventually went back to teaching. I started teaching part-time at North Carolina A&T State University at nighttime while I was working full-time during the day in industry. But eventually I went back full-time teaching at the university just as a senior lecturer. And it was during that time that I began to have conversations with my students and serving as an advisor or a mentor. And it's something that started to stand out to me as students were always trying to get in classes that were full. So I don't know if you can see from my picture, there's one person in a classroom, empty seats, and then there's this full classroom. And I started having these conversations with these students because, mind you, this is the institution that I graduated from. So a lot of the math professors were still there, and they are still there today, believe it or not. Yes, I'm older, I'm quite older, but they are still there. A lot of them are still teaching, but the students were kind of avoiding some of these courses. And I was trying to figure out, like, why are you trying to get me to override you into these classes at its maximum, but yet you have all these empty seats in this other class? And it really made me kind of come back and bring my focus on teacher knowledge. Like, what is it about knowing that connects with students and encourages them to want to be in these classes or not? So that's kind of a little background of how I got into this realm of trying to explore teacher knowledge. This quote right here is one that's always kind of made me laugh. It's like, for teacher knowledge, you must know considerably more about the topic than you ever expect your students to know and learn. But who tells us what more is? And so I started on this pathway of like, well, what do you mean? What more should we know? Some would agree that it's definitely more than content knowledge. So it's more than your basic math facts, okay? It's more than your theorems. It's more than your calculations. Others would agree that it's unique to teaching. So it's something that mathematics instructors or science instructors or English instructors, they have this type of knowledge that others that may not be in the teaching or provide instruction field, they don't possess. And it's also multi-dimensional. I mean, it's not just this is one thing, it's this thing that has different compartments. And so lucky for us, and I consider this lucky for us, there are colleagues that are in math ed, more focused on elementary math ed, that came up with this mathematical knowledge for teaching framework. So this is by Ball and colleagues. Now, this work was based on elementary ed. And so what happens in this framework is basically two overarching domains of subject matter knowledge and then pedagogical content knowledge. And then they break these domains down to subdomains. There's common content knowledge, there's horizon content knowledge, there's specialized content knowledge. And then on the pedagogy side, there's knowledge of content in students, knowledge of content in teaching, knowledge of content in curriculum. And just for time, I won't go into details of those, but if you want any information about those or want to talk to me later, I would be glad to share. So what's interesting about this work, I think, is that the work on the elementary level, they have shown that the MKT, that's short for mathematical knowledge for teaching, has been connected to student achievement and also quality of instruction. But again, I remind you, I'm at the university level. So I'm looking at instruction there and I begin to question, what do we know about post-elementary school MKT? So I started to take a dive into the literature. And mind you, this is my dissertation. So this is back in 2020, around the time that I finished this. So at this time, I started to look specifically at MKT at the secondary level. And so what was interesting to me, the studies that did exist, the nature of the studies was like somewhat different. There are investigative studies which really tried to align like the relationship between MKT and practice. Then there are these developmental studies where actually trying to develop measures of MKT, yet I was still questioning, what is MKT post-elementary? What is MKT secondary? And then these are these evaluative, which were kind of trying to rank teachers on their level of MKT, like how much MKT do they have? So some scholars have said that, you know, this is very disturbing if you look at the secondary, just the variety that's going on. And so even within that variety of things that were going on within the secondary studies, how they studied MKT was different. Some of them did look at it as subdomains, as compartments, but others looked at it as just this one thing, like it's just this knowledge, and that's what it is. Those that broke down the subdomains, which I think is even more interesting, it's like, how did they define these subdomains? Some went back to the definitions that Ball and colleagues provided, while others simply made their own definition. So you see kind of the concern here, if you're looking at like MKT at the secondary level and trying to get an idea of what it is, there's so much difference going on. And finally, who they were studying, like in these empirical studies, were they looking at prospective teachers, those undergrads that are going after their teacher licensure, or are they looking at practicing teachers? So again, there is literature on this that says, you know, this is quite disturbing, this variety. But for me, I said, you know, how can I use what exists to build a greater understanding of what this MKT looks like at the secondary level? So you might say, why? Why does this matter to you at all? And I always like to start with my significance. My thing in looking at this is equitable teacher preparation and development, also support for practicing teachers. Like if we have this varied idea of what makes good mathematics instruction, there's lack of consistency in our preparation and development of programs. So I think this is a major reason for me wanting to go into this area. And so of course I had to balance this study. I couldn't study everything relevant post, you know, after elementary school. So I had to narrow in for my dissertation, because I'm sure you all know you got to get that dissertation done and you got to keep it moving. So I had to kind of narrow it in. So my research question was, what is the nature of the knowledge expert mathematics educators use when engaging with written student work on quadratic function tasks? So again, tried to bring it in so I could get my dissertation done. So I used an exploratory multi-case lens, or exploratory multi-case study with a lens of appreciative inquiry. And I put that in there because being a mathematics instructor with over 20 plus years of experience and teaching some of these things that I was studying, I really needed to be aware of my biases. So I use this appreciative inquiry because I'm trying to look for what exists versus what did not exist. So continuing with my study overview. So I had these cases and I will call those experts. So these are the people that I interviewed. There were 2 high school mathematics teachers. There were 2 mathematics teacher educators, and that meant they had done doctorate studies in mathematics teacher education. Then there were 2 pure mathematicians, again, that had gotten their degrees, their PhDs in pure mathematics. Together, this group of what I deem experts, they had like over 170 years of teaching experience from the high school to the college classroom. They also had amassed like numerous recognitions at the state and regional level. And then they were committed to mathematics teacher education, whether they were doing professional development in the state or serving in leadership roles in their schools. So those were my cases. Again, I'll reference those as the experts. So for data collection, I engaged my experts with student written quadratic function work doing semi-structured task-based interviews. And we also had a concluding focus group where I brought all my experts together at the end. The interviews were individualized, so each expert did their own interviews, and we did a series of interviews, but at the end we had a concluding focus group. And so for my analysis, went through phases of using hypothesis coding and thematic coding, and also did a lot of member checking in between. So that's just a little overview about my study. Now, before I continue to talk, I'm gonna get to take a break, and I need your thoughts on something. I want to engage you for a few minutes. Behind this sheet of notebook paper is going to be a sample of a student work. And so what I would like for you to do is when you see this sample, of course, I'm gonna take the paper down, I'll read it just in case someone can't see it or that not looking at the screen. I want you to write down your thoughts and try to be intentional, like whatever that first thought is that comes to mind, put that down. And I'm doing this for a reason, and we'll talk about that a little bit near the end. But whatever is the first thing that pops into your mind, and if you don't write, just make mental notes of like the order of your thoughts. And we'll probably give you just a minute to look at this problem and just anything that comes to mind. But the order is important. Okay, so here is this problem. Can everybody see that? So this is a sample student work. It says circle the function that will produce the widest parabola. And so A is f of x equals 2x squared plus 6x minus 3. And up under that, there is a left bracket, negative 15 halves, comma, infinity, right parenthesis. And so B is f of x equals a negative 1/7 times x plus 1 quantity squared. Up under that is a left parenthesis for negative infinity, a comma, a 0, and a left bracket. And then C, and this is the one that the student has circled, excuse me. It says f of x equals a negative 5, x minus 1 quantity squared plus 7. And up under that, there's a left parenthesis, a negative infinity, 7 with a bracket. Now I'm going to be quiet for a minute, and so you can record some of your thoughts. Is everybody good? Does anybody want another few seconds? Thumbs up. Everybody looks okay? Okay. So you actually kind of disengaged with what my experts did. Basically, they were given a piece of work and they were asked to think out loud though, or you were writing down, but that's kind of what they did. So we're going to come back to this problem at the end. We'll have a little discussion, hopefully have enough time to come back to this. I just didn't want to bias what your thoughts were. That's why I wanted to do it before I went into the findings from my study. So let's see where. So again, the question is, what is the nature of the knowledge expert mathematics educators use when engaging with student written work on quadratic function tasks? So in order to address this question, I had to borrow from ontological studies and philosophy, and where ontology is considered a systematic account of existence. So basically, if something exists, then it can be classified, okay? And so I'm using these entities as my categories of teacher knowledge. So then there's a relationship between these entities, and that's basically the interactions or connections. And then these entities, once I have these categories, I can kind of put them into a class. So that's the way I will present my findings to you all. So now, before I go into findings, I want to share, I pulled a sample to share my findings. So sample experts from my interviews, but it's based on this problem. So we don't have to think about this problem. I'm just going to tell you about kind of what this problem is and show you a few of the student samples. First, I just wanted to show you the problem with no work. It's basically they're given tables, and it says which one or ones represent a quadratic function, and how do you know? And then please explain. And so there's space for the student to write their solution choice and then to write their explanation. And so there are 4 tables here. So now this first student replies none. And it said why? It says because quadratic functions are a mirrored reflection, so they look identical on each side, which would mean, for example, then they give a nice little table of data, and then they have an image. So that was their response. And just another example of a sample of work. This student, you can see beside the tables, they're doing some type of calculation, and they respond that table B and D represent quadratic functions. And how they know is they said the rate of change from number to number is a constant number, and then they show what they mean. So you can see they have this little +2 boxed in on the left, and on the right, they have ×3. So that was their response and reasoning why. And then we have, I think this is my final sample. So this student has drawn graphs, it appears, for each table. They answer B, maybe, but the table needs more points. They have a question mark beside their D graph. And it says, I graphed to see which one looks like a parabola. B may be 1, but I would need more points to be sure. So these are just some samples of the student work that the experts were able to talk about. And I did pull some excerpts from the interviews to kind of make sense of my entities based on this work. So my 6 entities for defining the nature of knowledge for expert mathematics educators. The first one is content knowledge. So if content knowledge, this category is basically knowledge of quadratics. So when I say quadratics, I mean functions and equations. And it's the mathematical ideas, concepts, definitions, and procedures that are foundational to quadratics. So for example, in the excerpt, it says, my definition of a quadratic is, they give that, and where A is not equal to 0 for recognizing quadratics from table data, I would look for a constant second difference. So again, this expert illustrated their content knowledge. They basically give the formula for a quadratic or standard form for a quadratic function. And then they talk about how they would determine which table represented quadratic data. So that's the entity of content knowledge. The next entity is connections. And this is the knowledge of mathematical concepts that inform quadratic learning and understanding. And then it goes the other way. What else will knowing about quadratics inform? So an example from the excerpt from the interview is if students know linear functions, they could recognize a constant rate of change and determine which of the functions are not quadratic. Further, they say these multiple representations, equations to graphs, will be used in calculus. So you can kind of see in this expert's response, there's a link between linear functions and understanding quadratics. And then they take this use of multiple representations. They're talking about the tables, the graphs, the algebraic form, how that's going to be used in calculus. Another entity was interpretations. So this is the knowledge of mathematical ideas or concepts represented in student work. So this is basically when the expert went in and they tried to interpret, unpack, explain the mathematical ideas that was in the writing provided by the students. So this excerpt says, this student did first and second differences. Since it's a common ratio, the student thinks it's a quadratic too. The next entity is anticipations. And this is knowledge of anticipated student methods, strategies, procedures. This is basically, what do you think that student's going to do? And then why do you think that student's going to do that? So this expert said, you know what, as soon as they saw this problem, they said students will graph. That's just what they anticipated. That could be based on the expert's experience and what they've seen in the classroom through the years. Further, they say they did not see that symmetry in any of the tables. They are going to answer that there are no quadratics represented in the table data. So this response is kind of justifying or giving that reason of why the student did what they did. Then there are the instructional moves. So this is a knowledge of basically the teacher moves or the next technique that will kind of push the student learning further. Like, what would you do as a teacher? So an example here, this expert says, I would ask, do quadratic functions always have a vertical line of symmetry? And is it possible that there would be a line of symmetry not at the y-axis? So this is kind of that instructional move, just trying to just push students learning or build upon what has been shown through their learning. And then finally, the last entity that we use to describe the nature of knowledge for teaching quadratic functions is resources. So this is the knowledge of instructional materials and resources such as technology or curricula that can aid in student understanding. So an example of this from the data is the interviewee says, put the data in the calculator and see the plot on their calculator. That might be a little more efficient than having them plot the data by hand. So an example of a resource here is using the calculator. And I'll just take a moment there to see if anyone has any questions right here before we move on. Okay, all right. So these entities, again, further analysis revealed that they could be classified. If you think about the content knowledge and the connections, the focus of both of those is the mathematics. Like, you know, those basic ideas and concepts, and then the connections across the curriculum. So math was the focus. So that was the class of that entity. If you think about interpretations and anticipations, where is the focus going here? The focus is going on the student or what the student did. And then lastly, the instructional moves or the resources, where does that come from? That's the teacher. So within these 6 entities we have, I was able to classify them based on their focus. So we have the math, student, and teacher focus. Now, again, continuing with data analysis, there were some relationships that existed between these entities. And this first one is content knowledge as an enabler. This was revealed by going through and sequencing the order in which experts made their responses. Like, what's the first thing they said? As soon as they saw that student work, what did they do? And so we realized with this set of experts, the first thing they were doing is they were sharing their content knowledge. And that's why I wanted to see what you all wrote down first, because what my experts did, as soon as they saw the work, they were talking about what they knew before they even dove into what the student did. So for example, just tracing this data, this participant first started with that. I know that the shape of a quadratic, I know what the shape of a quadratic looks like. It is a parabola, which has a vertical axis of symmetry. That is the first thing they saw with that student work. Then they went on to talk about what they anticipated, and you can see the connections. Like, they talk about the shape, but they anticipated if students don't know what it looks like, they're referencing back to that shape that they knew, they will not graph. They said the student is looking for symmetry. That again is relevant to what that expert knew about the shape and the symmetry of a quadratic. And then they were able to make connections, anticipations, they all related back to that content knowledge. So in these particular findings, content knowledge was shown as an enabler. It enabled these other entities. Then there was a synergy between entities, which I've talked about a little bit already. There's like this connection. Like, if this student is looking for symmetry and the student is showing symmetry in their table and graph, if that was their interpretation, then they could anticipate like why the student did what they did. They said, since they did not see that symmetry, which is connected to their interpretation, they're not going to graph. And then their instructional move, well, I'm going to encourage the student to get more points. Well, why would that person do that? That's all based on the fact that they were looking at symmetry. And then they talked about the resources they would use. So even within our entities, there are 2 main relationships that came up. This content knowledge is an enabler. It's like foundational to the other entities. And then there was this relationship, these connections between the other aspects of their knowledge. And so that kind of led me to present this conceptualization of how, like, it showed up in my study as content knowledge is centered. It is an enabler, but there's this connection between all these other domains. And so if you think about the first diagram that I showed you of the MKT framework, which I know people commonly refer to as a ball, the egg, ball's egg, this looks a little bit different. And hopefully it kind of represents the interactions between all of these entities. Now, whoops, went too fast on that slide. So that was the first major thing came out. Like that was kind of answering my question, like trying to understand this knowledge. But you keep on going with your analysis, and something else came up. And this is the thing that I get more excited about because I'm a practitioner at heart. I'll just tell you that now. This is what excites me. I went back through the data, and anytime an expert started to say this student, pulled all those like remarks together whenever they started with the student. So this student is looking for symmetry. This student uses second difference. This student sketches. This student follows. This student. And we were like, wait a minute. What are they answering? There's a question being answered that I didn't pose. Remember, I gave them the work and said, share your thoughts. And so they were answering this question, what mathematical understandings or ideas is the student demonstrating? So I'm gonna give you a chance to kind of engage in case I've put some of you to sleep. This was a second trace. Now I did not put the prompt up here because if I put the 2-word prompt, then it would give it away. But look at these comments and see if you can tell me what question you think is being answered. Again, I didn't pose these questions, but some of the data for this is ask student more questions, demonstrate implications of multiplicative constants, ask students, assist student, show student, help student, review zero product property. What question do you think those are that's being answered by those remarks? And there's no wrong answer, okay? Nobody's gonna guess?
They're typing in the chat.
Oh, older people I don't multitask well. Here we go. Next steps for teacher. What would you do next? Exactly. That's exactly what we think they were posing this question. Let's see if I can get back here. What could I, the teacher, do? So again, I didn't pose these questions to the experts. This is just going back in data analysis, looking at my data a different way. And so again, I told you this is the thing I get most excited about. I have a paper under review right now, and it's based on a strengths-based approach to examining student work. So while again, my goal in this study was to understand more about MKT, what came out of this is something that's hopefully useful to teacher educators, teachers, even, looking at student work in a way that builds upon what students know. So we came up with these questions. What is the solution? And that really goes back to your content knowledge. Remember, that's usually how my experts started any of the engagements with the work, is telling me what they knew about and what the answer was. So what is the solution? And then what mathematical concepts inform the student work? What would the student's work inform? So those are both math focused. Then turning your attention to the student, what mathematical understandings is the student demonstrating? And what additional understandings is the student likely to have, or what should they learn next? And then finally, coming to the teacher is what could I do to build on students' understandings, and what resources could be helpful in extending the student's understanding? So I'm proposing that we can use this as a tool to take a positive approach to looking at student work. Sometimes, and I can talk about myself teaching for years, sometimes I'm going in marking if it's right or wrong. But what if I took a moment just to step back and look at and build from the students? So I think there are major implications here. One is this can be a personal tool for teachers, just to kind of engage more meaningful ways. And I know, yes, you cannot do this if you have a class of 60 every time you give an assignment, but maybe this can be useful to you. It can also inform your instruction. And then for mathematics teacher educators, it can inform pre-service and practicing teacher activities. You have a way to engage with practicing and pre-service teachers to possibly expand their MKT. And so then, of course, I go back to my diagram, and my hope here is that we can do some work to move the secondary MKT, even the studies, the work that's being done. And of course, I should acknowledge, we call this secondary because of the fact that quadratic functions are introduced at the secondary level typically, right? But you all know that this is very much so a college concept also. So just framing this there, I'm hoping that we can do some work to push our understanding of beyond elementary school, what MKT looks like. And for a researcher, I think the implication here is that we have evidence now that secondary teaching knowledge can be described in detail. We've done that in this study. And I think there's more work that needs to be done so that we can build to this conception. And hopefully this conception will be a useful tool in that study. Again, for mathematics teacher educators, if that's the route that you're kind of trying to go, you can inform pre-service and practicing teachers activities for both MKT, so thinking about mathematical knowledge for teaching, and for quadratics. And so I'll end with my agenda. So of course, my questions start about like, what is the nature of mathematical knowledge to teach secondary mathematics? And then how do we support this knowledge is really where I'm trying to go. And so hopefully this application of this conceptualization of MKT, I'll have the opportunities to take it outside of what I did, you know, more than just quadratics. What is it going to look like if we're doing exponentials? What does it look like in a classroom for observation, where of course my data was collected from interviews? So I hope to be able to take this to other content and context. And again, I'm excited about the tool for pre-service and practice and teaching. I'm hoping that becomes a thing that we will be able to use, you know, just to help inform our instruction when we're engaging with students and learning about their work. And then with my work at on the Elite PD project with Mary P. and David, I'm hoping to begin looking at these connections between this equitable and inclusive instruction and MKT. So that's that. So now back to this part, maybe I can hear from you all and see if you all were similar to my experts in your thinking. So I'd be very interested in the thoughts you wrote down about this problem. Silence.
I wondered how students were interpreting the word widest. Like what does widest mean to them? We have an idea of what we want them to think in terms when we use the word widest, but having taught college algebra quite a bit, what we think they should interpret it as is not necessarily aligned with how they are interpreting it.
Exactly. Very good. And
they'll put that in the chat too.
That aligns with one of my, I think it was my mathematician that said, you know, that's not very well defined, because she went totally to working, like fixing this problem, this question, versus looking at the student work. So yes, did see that. Anybody else?
I would just, go.
Please go, Susan. Go ahead.
Mine's brief. I was just going to say that when you talked about what the experts did, it resonated in the sense that you started with the content and you're like, what do I know about parabolas? What are the characteristics? And then you start looking at the student work to see what evidence there is of their kind of recognition of those characteristics that you were keying in on. That's all I was going to say. Colin, go ahead.
I was impressed with, well, really, when Mary said that she first thought of her definition of widest and how that might not match what someone else would read, I did think that, but I didn't write that down as the first thought. Yeah. You know, and then maybe it's just that I'm not as experienced in metacognition as Mary has been lately, thinking about how she thinks and having students think about how they think. But I didn't catch that. The first thing I actually wrote down was just like, well, I wanted to solve it. And I was like, oh, well, they chose the largest coefficient rather than the smallest one, right? But in reality, the first thing I actually thought was, I wonder what they think is, like, whoever's reading it, I wonder what they think widest means.
Exactly. Yeah, good point. And I see in the chat says, not a mathematician here, but one thing I noticed was there were answers, but no more work, right? So what is that stuff under there anyway? Cool. Any thoughts on that? This is always a fun problem with my experts, because a lot of times I'd be quite frank with you. Eventually, once they got through widest and what they knew, talking about, the things they knew, they were like, what are they doing? Took them a while to figure out what the student had actually done. And I think it's really interesting what this student has done. Although they don't show very much work, they give you these things. And I was trying to be intentional and not read out like the interval. I was just trying to read, bracket, whatever. Has anybody thought about what they actually did here?
Well, somehow they're connecting the range to the word widest.
Right.
And so, yeah, I would definitely want to talk to him. I'm sure if Sloan saw this, because Sloan has done some cognitive interviews with college algebra students as well. But yeah, what is the connection the student is seeing between range and the word widest that may influence why they're selecting that?
So it goes back to what you started about widest. Like, what's their orientation to widest?
Yeah.
Are they thinking, horizontal, or are they thinking vertical? It's a very good thing, very good question. So yeah. So you all were in line with pretty much what my experts, kind of thinking about the problem itself, thinking about what you knew about that, and then kind of diving into their work. And I think that's important for me because sometimes as a teacher, we always jump to what are we going to do first? And that's even with my tool. With the tool, we kind of want to focus on the mathematics, right? Focus on the student, what the student has shared, because it's going to value the student if you can build from their work, and then come back and say, what can I do to help? It's kind of changing that role instead of me jumping in first. Oh, that's wrong. I have no idea what you did, and just saying that's just wrong. So very good. Thank you for engaging with me in that problem. And so let's see, I have my references and then I'll just say thank you. And I guess we have time for questions. And I always end with this picture. This is a picture that my daughter drew. I don't know if Mary and David have probably seen this sometime before. Doing my dissertation work, she was in high school and all I was doing was quadratics. So I always like to have her image up there, just remembering that time. So any questions? Thank you.
So Stacey, I did not get to say hello. I want to make sure I say hello. I'm Bill Zahner and the director of CRMSE. So welcome, and I'm so glad to have you presenting with us today. So first, I want to say thank you. It was such an interesting presentation, and thanks to Mary for getting us organized, and Donna for bringing this meeting together. So, one question I'm wondering was how you thought the questions that you, so I'm like really interested in this topic too. So I like this topic as a thing. And the tables definitely made me think of a high school classroom observation I did once where the teacher, it was an integrated math 2, so they were supposed to be doing quadratics, was reviewing converting from a table to an equation and a graph. And so the first 2 were linear, and then the last 2 tables were quadratic, which are considerably more difficult. And what was so funny was the teacher did the first 2 and then said, well, I think we're good to go. Let's move on. And the administrator said, wasn't that a great lesson? I said, he didn't do the hard ones. But I guess I'm curious. So anyway, getting back to that, the thinking about interpreting the table is a really interesting one. And I guess I was curious how you came to those questions, or what process did you use to choose the prompts for your interview questions? And were there any like really great questions that you wanted to include but couldn't, or real duds that you got rid of that you can help other people avoid those problems? So just curious if you could tell us a little bit about that process.
So you're talking about like the mathematical tasks that I shared.
Yeah. I guess I was kind of thinking about how you chose those tasks and not others, or something like that.
Yeah. So I did a little pilot study, interviewed a few teachers before, just trying to figure out what was common in my state for quadratic learning and some of the issues that were seen or considered seen or challenges that students may have. And that's kind of how we selected problems. There were a lot more problems, but I think the rich data came out like from the table. It came from the one that we just saw with the widest. There was also like a word problem that could be handled in different ways. And that was another thing, thinking about tasks. Like there's this word problem that some students just, kept on like adding the number up until they got wherever to kind of generate the solution, versus some realized that it represented a quadratic and they immediately went to graph and saw where it crossed the x-axis. So kind of things like that, having conversations with teachers that were in our kind of the state, them identifying problems and then going from there. And then problems that had multiple representations too. That could be done in multiple ways. Like we didn't do too many, like just, factor and solve the quadratic per se. We wanted problems, or I wanted problems that just had multiple representations.
Awesome. Thank you. That thinking is very helpful. I appreciate you sharing the kind of behind the scenes look.
Thank you.
Maralise, go ahead and ask your question.
I can't hear Marlise.
I'm not either. Could you put it in the chat for us? Thank you. While she's writing that, Stacey, I was wondering what pieces of the dissertation work do you see that relate directly to the project that you're working on now? Where's the overlap in the two?
When I consider equitable and inclusive instruction, I consider a major part of that is the ability to use multiple representations. And I think that connects back to your MKT. So when we're thinking about, we're having graduate students that are coming in, possibly teaching for the very first time. And I believe that MKT is kind of gained and developed through experience. So there's this thing, right, that's going on with them teaching the very first time, and we're trying to engage them with equitable and inclusive instruction, but how developed, how expansive is their MKT? So I think that's where my connection is, and that's what I'm interested in.
Right, so she says, my question pertains particularly to vocabulary. Does choosing a different vocabulary allow for student direction in solving problems?
That wasn't exactly a part of my study, but from teaching, I think that that's a definite thing. Like if we had that word widest, right? If that was posed to them in a different way, or even in their instruction before they see the actual problem, if that conversation had been in class to really dive deep into what we mean by widest, I think that definitely can make a difference. So I think, yes, vocabulary is very important. And again, we just pulled student written work. Maybe another part of that was to be able to go back eventually and expand the study by actually talking to some of the students, in their thinking in that process. I don't know if that answered your question. That's okay. Okay. And that would be a very interesting study though, right? Posing that question in different ways and seeing the different responses that you would get from students.
Follow-up question is, how is vocabulary used, colloquial vocabulary, to reach a wider audience, and if that detracts from preparation? How students fare later in their mathematics training?
I think those are really good questions. I don't know if someone else can answer those, because again, that wasn't necessarily my line of study, but so I wouldn't be able to tell you from a research. I could tell you probably from a personal experience just with instruction for so many years that it definitely does make a difference. Getting to know your students is key. That's one thing that I've done as I've taught undergraduates through years, is really getting to know them and make connections. And then we can kind of identify those issues where there's maybe lack of understanding from the way the problems are posed or the way that I'm posing the problem in the classroom. So So I don't know if anyone else can answer that question from a research standpoint. I really can't.
Another question is, thank you for a great talk. Can you explain more on the process of how you used appreciative inquiry in your study?
So yeah, so appreciative inquiry really comes from the business world. And within that, one of the lenses identifying what does exist versus what does not. So again, I have years of teaching experience, and even in my interviews, I was not focused on what the interviewee did not tell me. I'm appreciating what they did tell me. I had to be very aware of that, but this is because of my background. So that's how this appreciative lens initially started. Now it's going to grow. I haven't really worked more on this part of my dissertation, but this can also be taken into the student work. That's a part that I'm kind of still dealing with. Again, that's kind of goes back to my questions, is valuing what the student has shown you versus what the student hasn't. And so that's how I use basically appreciative inquiry, just kind of to guide me in looking for what is there, you know, versus what is not. Okay, good. Yeah, and that was my first dive into appreciative inquiry. Luckily, I had a colleague at UNCG that has used it in her counseling work, and I'm trying to come across, because so many times, and even in the MKT, the secondary studies, I think I mentioned some of those were evaluative. Like they really hadn't defined MKT on the secondary level, yet they were trying to rank teachers. And I personally really had a problem with that if we don't know what it is. And so this lens was kind of got me out of that realm of saying, you know, they didn't say this and they didn't say that. It's just like, hey, this is what we know. This is what I've gathered from these 6 experts that are well known and well recognized in this area. So then another part of this was to repeat the study, maybe what we could consider inexperienced or new to the teaching profession. That might be one of my goals also, to kind of go look at that other side. Right now, I went to experts, right? Because I wanted to find out what it is. What do they know? Share with us, please. You know, how you've gained so much success. But now, what does this conception look like if we're just teachers that are just starting out?
I have like a comment, not necessarily a question. I just wanted to say I thought it was really neat how you sort of adapted some of those ideas from the egg into a more dynamic like situation, or like situating them more dynamically. And then because when I was first introduced to the egg, I thought of it as like, I'm going to collect knowledge in this part, in that part, in this part, in that part. And it was like really cool to see how you, even your figure was like really helpful. So thank you.
I appreciate that. And I think, and I was lucky enough to go to a seminar of Deborah Ball back in 2017, a summer workshop. And I think that was one of her things that she said, you know, people took this egg and laid it flat and said, this is all it, but I don't think they ever intended for it to necessarily be used that way. So I, again, value the fact that that was established, because if you read and go out in the literature, there's some people that says, no, this is not applicable to secondary education. And, you know, of course they have their reasoning for that, but I'm like, what can we learn from this? You know, this has been some ground level work. How can I grow from this? And that's what I started my analysis with. That was like the, you know, the thematic coding was kind of looking through the lens of this egg, so to say, of Ball's framework, and then growing from there, really being able to put more detail to it. Because I'm a practitioner at heart. What I do, I want to be useful. That's my purpose, you know. So how can we make things that make sense to people? So thank you.
Just one more comment. I think too, like as a you know, graduate student in getting ready to do a dissertation, even just your adaptation is valuable as a way for me to like look at frameworks and think about like how I might use them. So sort of like 2 layered there for me. Thank you.
Very good.
Stacey, I want to thank you so much for being here. I know that the folks who are on campus and needed to walk, we've lost them, and we have some other folks who even need to switch over to Zoom in 5 minutes. So we want to give them a little break. But we really appreciate you being here. It's really interesting work. I guess it's a little redundant, but I really appreciate that appreciative inquiry piece. And it's something for me to think about with science too. So again, thank you. And I hope that if people have questions, they'll reach out to you individually.
Yes, please do. And thank you so much for having me.
Bye, everyone. Have a great day.
Bye.
Good weekend.